Recording is rolling. It is Tuesday, September 3rd. I have the starter question for you guys. We're going to look at a little bit. Then there's a free response question on your desk. If I ever say FRQ, that's what that means, free response question. That's an AP style question. That's going to be our main focus today. Okay, by the end of today, before you walk out the door, I will get you guys your first quiz. It's going to be a take-home quiz. Most of these are going to be like that. We might have some in class, but I tend to make these take-home. Gives us more time in class to do labs and gives you guys, especially if I ask a more complex question that takes some deep thinking, right? It might take a while to go back and hash that one out. All right, so here's full page of upcoming due dates. You guys got your planners out? Planners? All right, here we go. Planners. So today, you guys remember this page was due. If you hadn't turned this into the grade tray yet, you can put that in the grade tray by the end of class today, and we're going to start grade those. All right, so that linear motion puzzles page, it's due today. You guys remember last week I gave you guys these college physics puzzles. Now, the only ones I'm going to score just the ones that I circled, right? You guys remember also, I know I mentioned this, but just a reminder, the solutions to all these are also posted on AP Classroom, right? The solutions posted, right? So those are, I'm going to pick up from you guys by the end of this week. So you guys got a few days there. Okay? Of course, I'll get you guys your take-home quiz by the end of today. So it's to the same due date, right? Which is going to be Friday. All right, AP Classroom, you don't want a progress check. Right. When I look at it right now, I think you guys will be ready to do that by this weekend. Right. So if I have you guys on pace and that ends up working out, then let's have that due on Monday. Right. So that involves linear motion, but also some projectiles. We're going to start projectiles tomorrow. So plan for today is we're going to wrap up a little bit of linear motion, do some review on linear motion. Right. And then tomorrow we'll start on projectile motion, which is the same equations as we've been doing. It just takes it into two dimensions. It's like, okay, throw a ball across the field. What's going on horizontally? What's going on vertically? We'll start this tomorrow. All right. You guys good with that setup right there? All right, you guys good? All right, here we go. So this starter question here. A ball is thrown straight upward. Oh, I'll give you initial speed. Let's say you can throw a ball 30 meters per second straight up. Okay. How high can the ball go? All right, so give you guys a little time to solve that. Who knows the answer? Who knows the answer? Uh, by the way, side thought, 30 meters per second, just for American context, that's about 67 miles per hour. So that didn't really matter though. Um, you guys probably are on a good track by now. So if you're really, really stuck, you guys know you're looking at these formulas. You can solve with these, right? And which of these would be most opportune to answer this type of question? Throw a ball at some speed, how high does it go? That's gonna, which one? The third one. Yeah, definitely, definitely. Right? Here's why. Here's why. Right? Do you guys see how the first two say how much time? Notice I did not tell you how much time the ball was rising for, and I also didn't ask for that. I mean, I could have, in which case it'd probably be one of these, right? But yeah, if you just have speed and distance, like throwing speed and height, right? Yeah, that's this third one right here. It's gonna stand. All right. So you guys got that. So go ahead. How about now? Who knows? Yeah, what you guys say?
I think 45.
All right, so I got it. 45 meters, 45 meters. All right, awesome. All right, so let's start going to here before I here. You guys can solve any of these linear motion problems if you, any of these puzzles if you can identify how many variables. 3, right? No, I definitely explicitly gave you one, the throwing speed. Well, what could possibly be implied? What else could you know? Yeah.
The acceleration of the final velocity.
Boom, boom. There you go. Yeah. So you guys, what's the acceleration? Yeah, you could say either 9.8 or 10 meters per second squared downward, which interestingly, that's the opposite of the direction you're throwing it. You're throwing it up, gravity's pulling down. You think there has to be a negative sign somewhere in this mix, right? And also, you said what do you guys know about the speed of the ball at the maximum height point? It would be 0 meters per second. That would correspond to this maximum height. Maximum height, I know the speed is 0 at the top. All right, so with all of that, start going through this solution here, solution. Right, so it's gonna look like this. So given 30 meters per second upward, okay, you know the gravitational field is pulling 10 meters per second squared downward, and those are different units. Right? And also the maximum height point would correspond to 0 meters per second at that point. For velocity, right? Right. Oh, and you guys said, let's pick this one right here. The sometimes called the time independent equation. All right, now I'm gonna do same thing I did last week is split my paper and solve it in terms of variables and solve with plugging the numbers in first. You could do either way, because it's good practice, especially for AP, to be able to solve in terms of variables. But I want you guys to see side by side. What if I plug in the numbers first? It would look like this. What if I just leave it in terms of variables? It could look like that. Right? And so either way, we're sending maximum height 0 meters per second. I'm going to go ahead and plug that in because that would correspond with the maximum height. Right? So try to solve that. Okay, here's my throwing velocity here. Here's as a variable. Here's plugging in the number first. And then gravitational field pulling 10 meters per second squared. Oh, notice I went ahead and threw the negative sign in here. You guys see that? Right? That can take care of upward versus downward. You see that? Okay. All right. So here's generic formula. Here's modified a little bit to the scenario. Right. Right. The rest of this is just algebra, isn't it? Just algebra switch around. And so maybe I can take the 2GH and add it over to the left side. It could look like that, right? Look like that. And then with the numbers plugged in, it looks like that. Right. And then very last step, right? Yeah. Exactly what say I got right there is 45 meters, 45 meters high. Could you just solve in terms of variables and plug in the numbers at the very end? Like if I plug in these values into this, am I still going to get 45 meters? If I do, throwing speed is 30. No, that's meters per second. Okay, I'm going to square that. Then divide by open parenthesis. Guys, in the calculator, make sure you throw this in parentheses down here. Otherwise, the calculator doesn't divide everything. Okay. All right, so I'll do 2 times 10. And that is, it's 45, and you know the unit is meters, just like that. Now, one of the advantages of solving terms of variables is that you can very quickly swap in other numbers. Like, what if there's another guy comes along and throws a ball at like 40 meters per second? How high is that going to go? You already have the solution. All you have to do is pop in the new number. Is it? Here, it's this fast. What if you could throw it 40 meters per second? 40, boom, done. I can throw 80 meters tall. Right? But if I can throw it 50 meters per second, boom, done. It's that if you solve in terms of variables, you just get all the answers real fast. Another advantage of solving in terms of variables is to handle this class of question of proportionalities. Like, what if I scale something up by some number? For example, right, what if I can throw 3 times as fast as someone else? So we're throwing balls horizontally, and somebody breaks out a radar gun, and let's say we got like Alan and Bob can throw 3 times as fast as Alan, right? 3 times 2. And now we're gonna throw it straight upward. Okay, well now we're back to this. Okay, guys, if you can throw 3 times as fast, how high is the ball gonna go comparatively? How many times as high? 9. Do you guys see 9? Right. Let me fix this real fast. Here. Okay. All right. Yeah. So guys, the quick way is this. The quick way is that scaling factor of 3 on that speed also gets squared so that factor 3 squared is 9 times. Okay? How about if you want to see some numbers? Like, I don't know if I quite see that. Okay. Remember, I was throwing it 30 meters per second. We can go back to that. And if you throw ball straight up at 30 meters per second, you can go 45 meters high. You guys remember that? Okay. What if I triple that speed? Guys, what's triple of 30? 90, right? So let's see how high it can throw. Now, I bet it's 9 times as high. Let's see if it is. Okay, so it's 405 meters as a hard number. Let's take those 405 meters, divide by 45, and what number has to pop up on my screen? Has to be 9, because it's a factor of 9. Okay, I can throw this high compared to this high. Should be a factor of 9. It's exactly 9. That's it. Okay, but yeah, I mean, as you guys do more of these, right? I'm going to ask that question a bunch, and AP is going to ask that question a bunch. Okay? So I scale up throwing speed by factor 3. That factor 3 gets squared, and it's 9 times the height. Boom, boom. Okay, I guess so. All right, everybody all right? All right, move on then. All right, so what if I reverse that question? Guys, I got a new question right here. Let's get this agenda off the board here. Let's get that. So now we're back to throwing the ball straight up in the air. Let's say, okay, we got Bob here. He can throw a ball, hey, 45 meters high. Hey, right? How fast can Bob throw that ball? Ooh, I bet some of you guys know without doing any math. What's the answer? Huh? Or go ahead and solve it. Go ahead and solve it. See what you get. Okay, yeah. There you go. You know the answer is going to be 30 meters per second because this is just the reverse of the previous question, right? Okay. So check this out. So here you go. Here's the given values is okay. Now I know how high I can throw the ball. Maybe I do something. Oh yeah. Yeah. Maybe I'm next to a big old building and I can say, okay, well I can throw it up to like the how high would that be? Like the 9th story window or something. So okay, every story is like so many meters, right? Okay, so I can figure out how high I can throw, right? That could be like a practical thing you do. All right, so I know how high I can throw the ball. I know gravity's pulling this way in the opposite direction. So I gotta keep track of my negative signs. And of course, at the maximum height point, that'd be 0 meters per second. So I can have a third kinematic value. I can solve this. Right. Hey, I wonder how fast I was throwing to start with, right? Well, guys, this is going to be the same kinematic formula we were playing with all along. Yeah, it's still the time independent one, still that third kinematic formula. So that's right? But now what I'm plugging in and what I'm solving for is going to be a little bit different orders. Okay? So let's try this out. So same thing as before. I got it in terms of variables on the left. I plugged in my numbers first on the right, but you know it's going to be the same thing. So okay, so maximum height point is 0 meters per second. Right? I'm trying to figure out the throwing speed, and I'm subtracting off because gravity's pulling down. Right? 2 times the gravity field times, right? And then what that maximum height ends up being, which is going to correspond to 0 meters per second speed at that point. Okay. And then the rest is algebra. Okay, just take the 2GH and slide that over on the left side. Point. That's going to maybe look like, okay, like that. And then the last step is to take the square root. Okay. All right. Oh, and look at that. As the numerical answer, it's exactly what you guys said it was going to be, right? Because that just goes hand in hand with what we did like 5 minutes ago. Right? I throw the ball up at 30 meters per second, it goes up to 45 meters. Okay, therefore, if I threw the ball up at 45 meters, I had to have thrown it at 30 meters per second. Okay? And then in terms of variables, ooh, it looks like that. You guys get a good look at that right there, or even better, maybe you're writing that in your notes. You guys are writing this in your notes. Okay? Is you guys see in square root 2GH? Guys, you're going to see that all over the place in physics. Right? So look for that. Maybe if you have like a bingo card of physics, you know, this be put this in a place where you can check this off a bunch. How about this? What if you did this? What if you go to the top of a building that's like 45 meters tall? Right, you guys got this? Right. What if Leaning Tower Pisa was 45 meters tall? And here's Galileo, and he's going to drop a bunch of stuff off. Right, 45. Right. First of all, do you guys think the light stuff and the heavy stuff is going to crash at the same speed? Yeah, it sure will. So it's independent of mass. We'll talk about why voids from now. Okay? And suppose you dropped it about 45 meters. Guess how fast it's crashing into the ground? It turns out to be the same expression, right? Because now the initial speed would be 0. So it's kind of this whole thing exactly backwards. So it's the same numbers. Okay? And in terms of variables, guys, this is always the crash speed. As long as you drop something, that's what it's going to be. Okay? I mean, it's almost exactly the same thing as this. Okay. How about this? How about this? Suppose there's a big old water tower. Maybe I'll draw this one out. Suppose there's a water tower. Big old, right? And it's full of water. It's got this pipe going down. And let's say this height right here happens to be 45 meters. Guess how, and let's say you open up a nozzle down here and water starts spraying out. Guess how fast that water's spraying out? 30 meters per second. Oh yeah, it's like that, right? How about height, some general height h, like any height? Guess what the speed is equal to? Square root 2gh is what it ends up being. Square root 2gh. Okay. All right, so let's just looking ahead a little bit. All right, so you guys good with throwing the ball up? You guys good? All right. Ooh, let's switch over to free response question. Free response question time.